In this video, we are going to see about extrinsic semiconductors. What is extrinsic semiconductors? Extrinsic semiconductors or conductors we have which is of impure atoms, right? We have silicons and phosphorus inside, and the right side diagram shows the boron. Okay, here acceptor impurity creates holes, and here donor impurities contributes free electrons, which is of n-type and p-type materials. N-type semiconductor, mainly due to electrons, entirely neutral, majority is electrons and minority is holes. In n-type semiconductors, majority carriers are electrons and minority carriers are holes. When a pure semiconductor, that is silicon or germanium, is doped by pentavalent impurities, which is of phosphorus, arsenic, boron, etc., 4 electrons out of 5 valence electron bonds with the 4 electrons of germanium or silicon. We will have 4 electrons out of 5 valence electron bonds to 4 electrons of germanium or silicon. Thus, the impurity atom donates a free electrons for conducting in the lattice and is called donor. Lattice is called as donor. The impurity atoms donates a free electrons for conducting. As conduction is due to a large number of free electrons, the electrons in the n-type semiconductors are the majority carriers and the holes are the minority carriers. As since the conduction is due to large number of free electrons, the electrons in the n-type semiconductors are majority carriers and the holes are the minority carriers. P-type semiconductor, mainly this is due to holes. N-type semiconductor is due to electrons and P-type semiconductor is due to holes. This is entirely neutral, similar to N-type semiconductor. Here the majority carrier is holes and the minority carriers is electrons. When comparing to N-type, majority carriers will be of electrons and minority carriers will be of holes. When a pure semiconductor is doped with the pentavalent impurities, the 3 valence electrons of impurity bond with 3 of the 4 valence electrons. When the 3 valence electrons of impurity bond with 3 of the 4 valence electrons of a semiconductors, these impurity atoms which are ready to accept bonded electrons are called acceptors. Okay. Here the 3 valence electrons of a impurities bond with the 4 valence electrons of a semiconductor. These impurity atoms which is ready to accept the bonded electrons are called acceptors. This p-type semiconductor material is also called as acceptor semiconductors. Fine. As conduction is due to a large number of free holes, the holes in the p-type semiconductors are the majority carriers and the electrons are the minority carriers. While comparing to n-type semiconductors, where the electrons are majority carriers and the holes are minority carriers, in p-type semiconductor, holes are majority carriers and the electrons are the minority carriers. Here is the difference between the intrinsic and extrinsic semiconductor. Intrinsic semiconductor is of pure semiconductors and extrinsic semiconductor is of impure semiconductors, and density of the electrons is equal to the density of holes in intrinsic semiconductor, whereas in extrinsic semiconductor density of electrons is not equal to the density of holes. Right? Electrical conductivity is low and here the electrical conductivity is high. Dependence on temperature only. Here the dependence on temperature as well as the amount of impurities added. We know that extrinsic semiconductor is an impure semiconductor. By adding the impurity atoms, we are going to conduct electricity. So extrinsic semiconductors are dependent on temperature and as well as the impurities added to it. In intrinsic semiconductor we are not supposed to use any impurities, so there is no impurities. Here the impurities are trivalent impurity and pentavalent impurities. Uses of semiconductors is that temperature sensor are made with semiconductor device. Temperature sensors, 3D printing machines, and used in microchips and self-driving cars, used in calculators, solar plates, computers and other electronic devices. Transistors and MOSFETs used as a switch in electrical circuits are manufactured using the semiconductors. Thank you.